Hello everyone, and welcome to today's webinar on demand-side management to demand response. It's part of the Dexma webinar series for this month. Today I have with me Miguel Cruz from our R&D department. Welcome, Miguel.
Hello, good afternoon.
Thanks for joining us today. So let's have a look at today's agenda, if we can. Here we go. So, from demand-side management to demand response is today's topic, and we're going to break it down in a few sections here. Miguel will talk for quite a bit of time, but I just want to remind you that while he's speaking, you have a questions box in your GoToWebinar panel. Please, at any time during the session, put your questions in there, and we will have 15 minutes at the end, 10 or 15 minutes, to get to your questions. Okay, so without further ado, Miguel, are you ready to get started?
Yeah, sure.
All right. So for those of you who don't know us, I want to introduce Dexma to you. We are the energy analytics experts, and this is what we do. We make energy management software that's recognized across the world, around, especially in Europe. And this platform is a SaaS platform. That means it's based in the cloud. It's called Dexma Energy Manager. It is hardware neutral, and this is a snapshot of what it looks like. And these are some of the companies around the world that are using our software. This is where you'll find it in a wide variety of industries. You can see from museums and culture to hospitality to education. Energy management is truly everywhere. Here you can see our global footprint of our partner community. These are our partners that distribute our energy management software around the world. And as you can see, it also covers many continents, many countries, and this community is growing. And if you are interested in joining our partner community, then get in touch with us at the end of the session. We're always happy to welcome new members to our partner community. These are some of the things that we wanted to share with you that some of the industry experts in energy management research are saying about us. So we're an exciting energy management company to watch, a key industry player. We've been in the business for 10 years, so although we have a lot of experience, we remain nimble, innovative, and always at the leading edge of technology. Part of that reason is because of our R&D department, who's always keeping an eye on the latest innovations in energy management. Right, Miguel?
Thank you.
It's true, it's true. So our philosophy at Dexma is that energy management is really made up of three parts. These are the three steps to holistic energy management: detect, analyze, control. So what does that mean? Detect is really understanding what's going on with your energy. How should you set up a baseline? What kind of assets do you have that are using energy? To get an overview of your situation, you need to detect your assets and see what's going on with your energy. And then you need to analyze and figure out where those savings opportunities are, saving energy and saving costs. And you need a solid analytics platform to do that. And only in analysis can you then control your energy costs. You need to make an informed decision for you to know what to prioritize and when is the best time to do that. And say you have a portfolio of buildings, then you know which ones to focus on first. So this is the Dexma philosophy: detect, analyze, and control. So why choose Dexma over all the other energy management software vendors that are out there? And there are a lot of them, trust us. Well, we do recognize that there are some features that come with your standard energy management system. Okay, maybe it's giving you dashboards and reports. Those are pretty standard features. Okay, it might even be web-based, which is an advantage over on-premise. We all know that. But what makes Dexma Energy Manager stand out is its advanced features. We're talking about an open API with an energy apps market that Miguel will tell us a little bit more later. We're adding applications to it all the time. You can even create your own with our development team if there's a specialized feature that you want to add. It's fast. Our partners are constantly telling us how happy they are with the speed and how much time it saves them in managing their energy, because of the platform is simply fast and has a really outstanding uptime. And as well, when we say hardware neutral, what does that mean? It means that most of the meters out there are integrated already into our software, and if it isn't, we can probably do that. We have also a webinar the past month that you can listen to about hardware integrations if you want to know a little bit more about that, or as always, get in touch with us. So without further ado, now let's get back to today's topic, demand-side management and demand response. And I'm going to hand it over now to Miguel Cruz, our Director of Research and Development at Dexma. Take it away, Miguel.
Thank you very much. Well, so good afternoon, everyone. So thank you, Nicole, for your very good introduction. So as we all know, reducing energy costs is among the core aims of energy service companies, energy managers, facility managers, building operators, but it can be done in several ways. So the aim of this part of the webinar, today's webinar, is to show how energy service companies can use demand-side management tools as a first step towards becoming fully demand response enabled, especially through technology applications that optimize energy consumption in heating, ventilation, and air conditioning systems.
So Miguel, tell us really why we should focus on buildings. Why do we talk about buildings when we talk about demand-side management in particular?
Okay, so the answer to these questions are the key drivers of international energy policy. So on the one hand, as you may know, energy policy is focused on ensuring the security of supply, so meaning secure energy supplies to ensure the reliable provision of energy whenever and wherever it is needed. Second key of energy policy is sustainability, so energy consumption to be sustainable through the lowering of greenhouse gas emissions mainly, and also ensuring competitiveness, so ensuring that energy providers operate in a competitive environment that ensures affordable prices for homes, business, and industries. So, given these challenges, which are the action areas that we can use to achieve these goals? So we have mainly three options. Build new power generation technologies, more flexible and greener. Also improving the grid, the transmission grid and distribution grid, and trying to find what the so-called smart grids. And the third step will be to undertake actions in demand side, in the demand side. So that's the name of the demand side management tools that will be discussing today.
Okay.
So what's the theoretical definition of demand side management? So it's any program that encourages the end user to be more energy efficient. So the implementation of demand-side management programs can range from improving energy efficiency with better insulation materials, for instance, to fully autonomous energy systems that automatically respond to shifts in supply and demand. So the more complex part of demand-side management is the so-called demand response. So demand response target short-term reduction in demand-side resources, meaning consumption during times of peak demand in exchange for financial incentives. And we will see later on them in more detail.
Okay.
So why is this important for Dexma partners? Because, well, the main assets that are integrated into our platforms are buildings.
Right.
And as we can see in this chart, for instance, in Europe, domestic and tertiary building account to almost 40% of the total energy consumption, and industrial buildings 7%. So let's say half of energy consumption comes from buildings. And if we see in more detail how this energy consumption is divided into residential and tertiary, we can see that tertiary has a very representative share. Is less than 50% and more times, but given their higher saving potential, their level of automation and its willingness to participate in energy innovation projects, main focus of Dexma and Dexma partners when dealing with demand-side management action must be in tertiary segment.
Right. And when you say tertiary, you mean commercial industrial buildings, anything that's not residential and non-domestic.
And non-industrial.
And non-industrial.
Yeah. Okay.
So what is the difference between these different categories then? I mean, we talked about demand response kind of falling under demand side management, but then you hear it talked about as sort of a superior over demand-side management. So what's really the difference?
Yeah, well, as I said before, demand-side management is any action that we can undertake to improve the energy efficiency at the customer premises somehow. And it ranges from the pure and basic conservation of energy that will involve like changes in behavior and the use of energy.
So turning the lights off and these typical things that you hear.
Exactly.
Okay.
And the next step will be energy efficiency, so making permanent energy reduction and getting the most utilization of every kilowatt hour consumed. Third step will be demand management, so that will involve the implementation of any energy management software or some kind of automation.
Okay.
And the top, more complex in terms of technical challenges, automation, but that can bring you more savings is demand response. That is the interactive interaction between the end customer and the grid, so that it can benefit from changing its behavior as a function of an external set point that can be a price signal or a physical set point, as we will see later.
Right, so the key is really once you get up to the demand response part of the hierarchy, you're going outside your own building to interact with external factors.
Yeah, yeah,
okay.
I will say that. So, and how to decide whether it's interesting for us to implement demand management or demand response programs. So, well, as Nicole explained before, going through the 3 steps of energy management as we always propose in Dexma. First, trying to detect by means of our energy grader, which are the savings potential in our portfolio of buildings. Then installing an energy management software to analyze the energy consumption in those buildings with the higher potential. And finally, in 5–10% of our building portfolio, depending on the segments we work, then implement control strategies to enable demand response and other automation technologies in order to reach the higher savings with the higher costs, but well, is the return of investment assessment.
Okay. So I heard you mention HVAC, and also in our white paper we mentioned HVAC a lot, but why do we really focus on that when we talk about demand response?
Okay, so yeah, well, because when dealing with buildings, we have to take into consideration that energy demand for heating, ventilation, and air conditioning accounts for around 45% of the energy consumption.
Almost half.
Yeah, almost half. So, and also it's important to notice that a careful inspection of the HVAC system can lead to energy cost savings with minimal investment and a relatively short payback period. Sometimes the problem is that the BMS is not well configured or something is not working properly, so only with the energy audit of the HVAC system we can easily reach very interesting savings.
Right.
The third point is that HVAC is a controllable load. The building management software can bring external access to the HVAC system assets. So the thermal inertia of the building also help us in the sense that makes the building to behave as an energy storage. So it enables the possibility to shift the energy consumption of HVAC different points of the day, depending on the tariff rates or the interest.
Can you expand a little bit more about exactly how that's done?
Yeah, well, maybe best option to explain that is by means of the examples that we will see later on. But well, at the end of the day, when we are talking about thermal inertia, we are making the building behave as an energy storage because the walls, the floor, the air inside the building behaves as a battery, and then we can temporarily stop or reduce the temperature set point so that we can shift the energy consumption from one point of the day to the other.
But won't this affect the users and how they feel and how comfortable they are?
Well, so if we manage it properly, it may not have any impact on the user's comfort. Because, well, as we can see in the next slide, that is one of the example on how demand-side management can be implemented in HVAC system. We have a comfort range. Comfort range meaning minimum temperature and a higher temperature for summer and for winter.
Right.
So in this example, the HVAC on-off optimization is explained. Well, this optimization relies on the fact that unfortunately most of the regular BMS currently operating in buildings are not equipped with this optimization functionality. It's hard to
it's hard to find this example.
Yeah.
Working.
But in case you implement the required automation devices, then you can make the building to behave as an optimized human behavior. So the human building operator cannot spend time doing comprehensive assessment in order to adjust the start time every day. So there is definitely room for improvement here when it comes to technology for demand-side management. Another example is the set point modulation. This is the case of winter. So the temperature set point modulation of the room provides an opportunity to use less energy during peak hours when electricity prices are higher. So this approach leverages time of use prices provided by the energy retailer and the building ability to store thermal energy, as we were discussing before. Mm-hmm. So during the winter, the thermal zone is seated to the highest limit value of the comfort range before the peak period, as you can see here in the middle. Uh-huh. Then, when the peak starts, the set point is decreased to the lowest limit value. So if this process is optimized, the cost of the extra energy used before the peak period is lower than the cost of the energy saved during the peak period. Okay. And another example when dealing with HVAC optimization is the free cooling. So the free cooling can be described as a technique that reduces the energy consumption by using outdoor air to cool the building. So this solution provides energy savings when the outdoor temperature is lower than the indoor set point temperature in the case of summer, for instance. So this method can provide up to 75% energy savings, so wow. It's quite interesting. And a healthy environment without compromising the comfort in the building. So that's one of the keys when dealing with demand-side management and of HVAC devices. Okay, so if I understand correctly, the three examples you just gave, the HVAC on-off optimization, the set point modulation, and the free cooling, these three examples are of demand-side management techniques. But not necessarily demand response if they're not interacting with external grid factors. So now, if we talk about demand response, what is the difference and how do we start with it? So first thing we have to say is that when dealing with demand response, other controllable assets have to be taken into consideration. Controllable assets. Yeah, controllable assets. So I borrowed these infographics made by you. Oh, I was wondering why it looked so familiar. So yeah, this infographic is available in the link at the bottom of the screen. So yeah, depending on the sectors where you work, you will have to focus on different controllable assets. So HVAC is one of them, but it's not the only one. It's not the only one. For instance, in the case of supermarkets, then you can play with refrigeration, you can play with lightings, and for instance, when working with healthcare facilities, most of them have a backup generation, and then you can combine backup generation on and HVAC modulation in order to optimize your load curve. So yeah, depending on the sector you're working with, then you have different opportunities. Okay. But in order to further understand why demand response is so important and what it's the origin of demand response, let me show the example of Germany. So as you may know, there is a nuclear shutdown ongoing in Germany. Right. We have some companies from Germany connected today to the webinar, so they will know it very well. But we have a problem in terms of the grid balance because in the northern part of the country we have the wind energy production concentrated, and in the southern part of the country we have solar. In fact, the solar PV capacity is much higher than the Spanish one, which is quite strange. That is strange. Yeah. Who would have thought? But well, so what's the problem they have? Well, now that the nuclear power plants are shut down, the power flow comes from north to the south, where the main consumption is. So transmission grid, at some points, it's quite collapsed and quite congested. Right. And the same in the southern part of the country, where the high amount of PV connected distribution grid, it's creating over voltages and it's causing stability problems at distribution network level. So that's why it's so important to involve the demand side of the system into the system optimization and operation.
Okay.
So which are the trends that are explaining demand response? Okay, the change from centralized generation to decentralized, moving from conventional controllable generation to non-controllable renewable energy assets like solar or wind power, and the moving from fixed or constant demand to automated demand. That's good news because it combines very well with the other part. Because which are the main obstacles? So as I explained before, grids instability, grid congestion, and also volatile markets. So which are the solutions? So smart grids and the changes in intelligent market, that the combination of both is a demand response. That is monetizing somehow the flexibility in buildings. Okay. So from a theoretical perspective, what demand response is and what's not. So demand response can be divided into two main groups, dispatchable and non-dispatchable. So consumers participating in dispatchable explicit demand response receive direct payments to increase or lower their energy consumption upon request. So this request may happen if the power line quality is decreased due to high demand or because of maintenance needs of device failure. So consumers can participate individually or through contracting third-party aggregators or retailers. On the other hand, we have the non-dispatchable demand response, that is also called as implicit demand response, where consumers expose their energy consumption to time variable electricity prices. So these prices are always part of the consumer supply contract, and they react to price difference without any commitment.
So the difference really is how much the consumers are participating or just getting different prices, if I understand?
Yeah, and how the utility can, to which extent, really controls the load reduction of the end customers. And because when you are only relying of a price signal, then you are not always 100% sure about what will be the response to the end, this price from the demand side. But when dealing with directly dispatchable or explicit demand response, then your reliability is higher in terms of grid operation.
So you have a bit more control in explicit demand response.
Yeah, that's why it's much more common to use this kind of tools.
I see, okay.
So here I will go quite fast through this slide because we're a little bit ahead of time. But well, just to show you what are the market potential of the different programs available in Europe and worldwide nowadays, we can divide them into three different options. What we call portfolio optimization, that is used by market players to meet their energy obligations in the market at the minimum cost. So it's kind of trading between different energy market agents.
Okay.
So the second is balancing markets, that is used mainly by TSOs to reach the equilibrium between active power and frequency of the system. Okay. Within this segment we can include capacity contracts or interruptibility contracts. And the third tier are the constraints management and markets at transmission and distribution system level. So here these are special markets to ensure the reliability and quality of service of the grids. And well, the potential earnings for participating in those markets is increasing from portfolio optimization till constraint management, but also the complexity and the need for automation devices and expertise to participate in them are higher.
Right, that makes sense. A higher return requires a higher investment.
Yeah. So having a look on the global market snapshot, and you can clearly see here that in North America, the demand response market is one of the higher right now, but in the future also Asia and Middle East have to be taken into consideration when dealing with demand response markets. When we have a look into Europe, then we have to focus on especially on Switzerland, France, Belgium, Finland, Great Britain, and Ireland.
Okay.
And we have to take into account when accessing these markets that only France and Switzerland have commercially active agreements in place for independent aggregation, including standardized roles and responsibilities of market participants. So these are the most major markets at European level.
Okay.
So what's the role of energy service companies and aggregators? So far, demand response market actors have been focused on the so-called low-hanging fruits, meaning large and highly automated industrial sites. Nevertheless, the power system needs for larger amount of flexibility, and then is when it comes the need for flexibility from tertiary buildings.
Right, so buildings come back in the picture now.
Exactly. So the energy service companies have a unique competitive advantage because they can combine their energy management expertise with granular customer insights to enable its participation in demand response programs. So demand response offers a great way for energy service companies to extend energy services beyond efficiency by earning additional savings and opening up new revenue streams for the customers, which is very interesting. So not only energy efficiency, but also additional revenues that can come from...
It's like adding an extra thing to the menu of services.
Exactly.
But don't aggregators do this? Doesn't it mean that ESCOs and aggregators will then compete for customers?
Well, not exactly, because energy service companies can take advantage of upcoming energy monitoring platforms which enable their clients to participate in demand response programs, but without having to take an aggregator role. Okay, they can set up agreements with aggregators and then offer flexibility from their buildings to these aggregators.
I see.
So, in fact, we can avoid competition between energy service companies and aggregators.
Okay.
So, energy managers will be able to gather more controllable loads across portfolios while providing additional capacity and facilitating the building of assets for aggregators and helping them to offer flexibility from buildings into demand response markets.
I see. Okay.
So before finishing presentation, let me show you some technical solutions we already have in place in Dexma, some of them under development, but one example is a quotic set of applications. So it works as follows. A typical building energy management software is embedded into a cloud system and has several inputs and outputs. So the cloud-based building energy management software is connected to the VMS within the facility and takes over control of different functionalities just as an expert human building operator or facility manager. If it has the necessary time, of course.
Right, of course.
So energy consumption and building status are sent from the VMS along with other relevant information like weather forecasts or electricity prices, and all of them are used as an input of the aquatic application. So as a result, HVAC energy consumption is optimized, ensuring a great building comfort. When mixing this new application with another two applications that are under development, are the rewards and trades, then we can also access demand response market. So if we mix the acts app with the trades app that will be available, let's say by the end of the year, we will be able to access implicit demand response market. And when mixing the acts with the rewards, then we will be able to access explicit demand response that, as we said, are the more interesting markets. Yeah. So aquatic rewards builds on the advantage of being able to control HVAC system to participate in explicit demand response programs, where the building's facility manager accepts to reduce its load by shutting down relevant energy-consuming equipment a given number of times per year for a certain amount of time, and financial compensation for providing the service. That's more or less how it works.
Right, so that's where the rewards come in. You actually can add a revenue stream to your business if you participate in these kinds of applications, right?
Exactly. So, okay. I think.
Oh, let's go to the next slide.
Yeah.
Here we go.
Okay, good. Well, so as a summary of all the presentation, I will say that the opening up of wholesale electricity markets, as described earlier, has opened up new opportunity for large energy consumers, such as commercial buildings, to step up their demand-side management efforts to reduce costs without sacrificing occupants' comfort. So more flexibility is needed in the overall energy system to match a surge in the production of renewable energy, and it's simply unrealistic for facility managers to be expected to adjust appliances, thermostats, or other energy-intensive system manually in response to price signal. So building automation and control systems are therefore crucial for participation in demand response and in active energy efficiency, as they provide the connection and reaction needed to link the building with the wider energy system. So no matter where you are in your demand side management journey, from energy efficiency to demand response, so it helps to know about the latest technologies that can facilitate it without adding to the workload of energy managers or building operators. So one example of this technology is Aquatic Acts, that we have seen. So Aquatic Apps is a building automation and control app that interacts with virtually any existing BMS to automatically fine-tune HVAC set points, thus minimizing the building energy consumption while ensuring the comfort of its tenant. So I really encourage you, all the attendants, to call us if you identify any potential project where we can test this new application, or if you see any chance to monetize the flexibility of your buildings in European or worldwide demand response markets.
Right, so thanks, Miguel, first of all, for that very informative presentation about demand-side management and demand response. We learned a lot. I want to imagine for a second that I'm an energy manager, which I'm not, but let's imagine that I am. And I want to get started. I think this is so exciting, this demand response markets, and I want to get involved. And I want my customers and my buildings that I'm managing to get started. So among the technologies that you mentioned, the best place to start is, okay, I think of my HVAC systems, and then out of the applications you mentioned, the Qualtic, Axe is the one I would start with. Is that correct?
Yeah, it's correct. It's currently within our technological portfolio is the application that we would like to use to control HVAC system to reduce the energy cost when using it for energy efficiency purposes, but also is the entrance door for demand response programs among Dexma buildings.
Okay, and that's already in testing mode, and we're accepting energy managers and building managers who are ready for this.
Yeah.
As we wait for the questions to come, just have a look and at the panel here for questions. You can enter them now. We have a few coming in. So there's one here about temperature set point modulation. This only gives flexibility to the grid and does not reduce energy consumption. Really, have you experienced reductions with this strategy? So thinking back to the set point modulation.
Well, yeah, I agree that the total amount of energy consumed is the same. Okay, because we are using the building as an energy storage.
Right.
But in terms of cost savings, if we optimize the set point modulation, taking into consideration the prices, then the total cost can be reduced.
So we're talking more about cost reductions rather than energy savings per se.
Exactly. Of course, it has to be taken into consideration the efficiency of the HVAC production. And then if we use set points that makes the primary generation to work in its optimal set point, then we can also save energy from in this regard. But main savings will come from energy price arbitrage.
Okay. And if an energy manager is in Europe, and you mentioned, we saw the sort of market snapshot, and Europe is the smallest out of the world markets that are getting into demand response. What reasons do you think are for that, and do you see it changing in the next few years?
Yeah, I think so. I think that, well, and in other parts of the world, this has been faster because maybe the needs they had were more focused on security of supply and reduction of cost. For instance, that's the case of Japan, where for obvious reasons and for security of supply reasons, they were one of the main countries implementing demand response in the last years.
Right.
In the case of the States, the problem they had is they had the oldest grid infrastructure in the world. So they had to choose between upgrading their assets or implementing this kind of smart grid strategies to make demand to participate in grid operation instead of investing in larger substations or larger...
Right, it's way more expensive to replace those things rather than take the pressure off the congestion, like you mentioned. We all remember that blackout I remember it, of 2000, when the entire eastern seaboard was just gone, and that was because of the grid was just super old, or it still is.
Exactly, and in fact that was of the kick-off points, one of the key time where it was decided that demand response was needed.
And it's funny how it has something huge like that has to happen for a country to say, okay, I think we should do something about this.
Let's hope in Europe we don't have to wait to that point. So the main driver in Europe is the integration of renewable energy sources.
That, this is booming.
Yeah. But well, it's not as strong as security of supply or cost reduction as it was in Asia or in the States.
And do you think that the EU will start pushing regulations to implement this, or are we already seeing that the government side is friendly to demand response?
Yeah, well, in fact, if demand response market are starting to blossom in different member states of Europe is because there's a directive, a European directive on energy efficiency in buildings, and there are a set of energy packages, directives promoted by the European Commission that are really encouraging grid operators to enable demand response in their grids. So we can see the example of UK, Belgium, and France, that they are really the forerunners. We have some countries lagging behind. This is the case of Spain.
What's the situation with Spain? I mean, Spain is just starting to wake up a bit with these auctions for renewables, and okay, they're realizing the energy situation can be different. But where do they stand on demand response?
Well, there is the interruptibility demand response program that is only for large industrial facilities.
Okay, so buildings are not so much part of the picture yet.
Not yet, and flexibility of the system is mainly provided by hydroelectric and gas-fired power plants. But this year there's an auction. There was an auction with 3,000 megawatts of wind power, of renewable energy sources to be integrated in the system, and now it's been recently announced that 3,000 megawatts more will be offered by the end of the year. So it will mean that a big share of energy generation will not be controllable anymore. If we combine this increase in renewables and also the reduction of the number of controllable power plants as coal plants or gas-fired plants that are being shut down, then the need for flexibility from the demand side is increasing. And it's good to see that TSO and main utilities in Spain are almost all of them involved in smart grid projects where demand response is being tested. So I start to see some green leaves.
some green light at the end of the tunnel, no?
Exactly.
So the utilities, that was my next question. It was going to be how the utilities are approaching this in Europe.
Well, there are some of them that are seeing it as an opportunity, and some of them are seeing this as a challenge because, well, it is changing the rules of the game so far, and well, where before the power of flexibility was in hydroelectric and gas-fired power plants, now aggregators and large consumers can have the power to offer this flexibility to the market. So this changes a little bit the order of stakeholders, and well, let's see how it's evolving during the coming years.
It's certainly an interesting space to watch in terms of these developments. Well, the utilities, maybe they're not so happy that the power is being taken away from them, and literally the power is being taken away, but that also means customers have more power if they want to generate their own power and sell it back to the grid. And so how do you see in Spain specifically, do you see it going more in this open model, or do you see it the utilities getting more afraid and maybe trying to prevent demand response from mainstreaming?
Well, there are things that you cannot prevent because, well, while the time is passing and technology is evolving, it's more clear than that renewable energy sources are the future. And if you have higher amounts of renewables in the grid, then you need more controllability. So I hope that during coming years, there will be a change in Spanish regulation, and it will be easier for individuals, for end customers to have their own generation assets and be more self-sustainable and approach our energy policy to the energy policy in Germany or other European countries that are moving in that direction.
Okay, we have a couple more questions coming in from the audience here. One of them from Maria says, what building management platforms are we able to integrate with these types of systems? Are there specific requirements? Can it be any building management system? Can any building really participate? Or
yeah, well, to be honest, so far we have only tested them with OPC protocol. That is a quite common protocol to connect with the BMS, and also with BACnet IP, that is another protocol. And this, not all BMSs in buildings or in the market are enabled with this kind of communication protocols. But, well, we are doing the effort to try to integrate as much as BMS as possible, and we are open for new proposals in case we can find pilot projects or commercial projects that require other BMS systems to be integrated. At least so far we have integrated like 5 or 6 different BMSs using OPC and BACnet IP, and of course we are open to try other technologies.
Great. We have another question related to renewables and combining energy management and renewables and maybe even demand response. So do we already have an example? You maybe want to tell us about solar.
Yeah, well, thanks for question, Eduard. So, yeah, in fact, we have another application that is called SolarView. It is especially designed for net zero energy buildings. So the main purpose of this application is to combine, as you say, on-site generation, maybe mainly PV generation, and other controllable assets in the building. And yeah, you can find more information in our website, and also a demo is available. So far we are focused on monitoring of self-consumption, but once we are capable to manage HVAC and other controllable assets, then this net zero energy building concept can be extended to a wider range of buildings.
Great. And maybe one last question here from Sergey. Examples of financial systems currently in place for demand response or an experimental phase with the main economic issue of demand side management is assessing the value provided by customers who participate. Would you agree with that? That is the main issue of determining the value and how to redistribute?
Okay. Well, indeed, there are some markets that are more mature for demand response, like the UK, where you have different segments and different demand response market where you can offer your flexibility. And indeed, there is a business case there, because if you can check the result of the different auctions, capacity auctions that have closed recently, and you can see the amount of earnings that you will receive for each kilowatt that you are offering as flexibility in the market. This amount can move from 20 euros kilowatt till 150 to 100 euros kilowatt, depending on the market where you are offering. So indeed, there is a business case there. When dealing only with demand-side management in terms of energy efficiency, so using HVAC modulation, for instance, then it depends very much on how the building is built, what kind of HVAC devices it has, if they are optimized or not, what's the total amount of energy that they are consuming over the year, and this will affect very much on the return of investment. And I would say that for HVAC control, it starts to be interesting for buildings larger than 4,000 square meters or something like that. But well, it's a case-by-case assessment that has to be done in order to answer the question.
All right. Well, that's all the time we have for today's session. I want to thank everyone who joined us and for all your questions. If you didn't get a chance to ask, then no worries. You can just send us an email. Our addresses are up here on the screen. Or you can tweet to us at Dexma on Twitter if you're into Twitter. Thank you so much again, Miguel, for your very enlightening presentation, as Eduard said. And please keep an eye out for our next Dexma webinar series. And if you would like to listen again in Spanish, we have the next one coming up at 5. So with that, I want to say thanks and goodbye to our audience.
Thank you very much to all of you.
Bye-bye, guys.
Bye-bye.